All right. The fast method. Has anybody figured it out yet?
No.
Not really.
If I had, then I would have done it.
Oh, I do care, but I just haven't.
I didn't know it was.
Okay, if I want to take the derivative of this, right now we have to go the limit as change in x goes to 0 of x plus change in x squared minus the function all over change in x, right? And so I get the limit as change in x goes to 0 of x plus change in x, and I have to FOIL this out. And I'm going to get x squared, x plus, or x change in x plus another one, so I'm going to have two of those,
In this is going to cancel.
plus change in x squared minus x squared all over change in x.
X squared is
Okay, so my x squareds cancel.
Everything cancels.
Not everything.
No, that's
So I can pull out a change in x, leaving me with a 2x plus change in x over change in x. Those cancel.
Oh my gosh, I just figured it out.
it equal to power down?
So how can I go straight from this to that?
Shove the exponent in front.
So this exponent comes out in front and becomes the coefficient. And then what happens to the exponent?
It dies.
Doesn't die.
goes down.
Subtract
Down
one.
by 1.
So,
That's how it works. You ready?
yes.
Oh my god.
Let's do some examples.
Retarded.
Okay.
1 is 3.
Yeah, one is
F prime of x. If I take the derivative of this,
it's 3.
no, derivative of 3. So if
it's 0.
it doesn't have an x, so it's going to be 0. So anytime you take the derivative of a constant, it will be 0. Right? And that makes sense because think about what this graph would look like. It's a y equals. It's going to be a horizontal line. What's the slope? It's going to be 0. Okay. Number 2, y prime.
It's going to be 3x. So it's like
This one, y prime.
9x.
Number 4, y prime.
Negative 2x to the negative first.
It's got to be reduced by 1.
Negative
Or negative 3.
There you go.
Negative 4x to the negative first.
Hmm?
Good joke. Why can't you show us this again?
You're appreciating it right now. 3 halves x to the 1 half. Very good. Okay, y prime here.
negative 1 half.
Two-thirds x
To the negative third.
Mhm.
X is negative 1 and 1/2 x. Or
Mhm.
Equal.
11.
Negative 2/3 x to the negative
Oh, okay, yeah.
5/3.
Good. Okay, this is a square root, so this one's going to take some manipulating around first.
No, because isn't it just 1/2?
There you go. So it's going to have to be x to the 1 half. Change it back to its fractional version, which seemed kind of like it had no purpose for the last 2 years. Now it does, because it makes taking the derivative a lot faster when it's a fraction. So then when I take the derivative of it, we've actually already done that one before. Same idea here. X to the, yep. Now this one is inside here, so this is a 3 in here. Change it first,
3 halves.
x to the 3 halves, so then when I take the derivative,
3 halves x left.
So real quick, is that 3 just over 1 and then you just multiply it by the 1 over it?
no, what number is out in front of here when I don't write one? A 2, so that comes out and becomes underneath the
Oh
denominator.
yeah, that's how it works.
Okay, and this 2 is inside here.
Amazing. 3.
2/3.
Two-thirds x.
Okay. All right, how about this one? This one deserves a rewrite as well. Y equals
X to the, or x times 1
This is a 1 over x right now.
Yeah.
Rewrite it. If I put an exponent in there,
One
fix
over
it.
for 1 times 1 over x.
Oh yeah, you gotta do like the.
Is it just 1?
Is it just x to the first?
Close.
Oh yeah, sure.
Because it'd have to come up. So I'd have to change the exponent to a negative. Then when you take the derivative of it,
Just negative 1x to the 0. So just negative x.
you reduce this by 1.
Oh, to negative 0.
Negative 2.
There we go. Okay, so this one again, this is going to be then what?
Negative
Well, don't take the derivative, just the y. Rewrite first.
X to the next
2.
one.
Yeah, actually.
X to the negative 2. Then when you take the derivative of it,
Negative 2x. Negative 3.
okay. But this one,
And
Okay, can we take test?
negative 1 over
No,
x to the negative 1
because
half.
there's another place like a
Yes.
say it one more time.
1 over x, or x to the negative 1 half.
X to the negative 1 half. Okay, so when I take the derivative, negative 1 half x
3 halves.
minus 3 halves, to the negative 3 halves. Okay, how about this one?
1/3. So like x to the negative 1/3.
Okay, so that's my rewrite, and then when I take the derivative of it,
1/3.
negative 1/3,
Yeah.
x to the
Forward.
4/3. Okay, how about this one?
X to the negative.
2/3.
Okay, derivative,
Negative 2/3 minus to the negative 5/3.
rewrite,
x to the negative 1/3.
not 1. What number's here?
2/3.
And that comes under here, so it's going to be x to the 3 halves negative. And then when I take the derivative of that to the,
Or to the negative 5 halves.
good. Okay, now what about this, when I have a coefficient out in front?
Straight.
Add it?
Nope.
Multiply it by
Yes.
straight.
So this now has to be combined with that
So it's gonna be
20x.
to the
Oh wow.
third. How about this one?
Negative 8x to the negative. I don't really care. Can we just do decimals?
Negative 26x to the.
What if we give you decimals?
So negative 2/6 is really 1/3.
Yeah, negative 1
X.
x to the negative 3 halves.
You're going to want to definitely keep them in fraction form, because when these are all very simple derivative ones, but when they get a little more complicated, they're going to be fractions will be in the formulas, so you'll get canceling and stuff. So you want them to be fractions. Wow, what happened to that one? Let's equals y, I guess. Not sure what happened to that one exactly. So I take the derivative of that one.
It's confusing. I don't even know.
2/3
Negative
x to something.
Well, what's this one's x power?
0.
1, so it'd be 2/3 x to the 0. X to the 0 is,
What?
so what would I get?
2/3.
2/3. All right, so you're going to see that a lot. If you just have the derivative of 5x, you're just going to lose the x, and it's just going to be the coefficient. Right? Oh, which happens to be my example.
5.
Negative
Negative 3.
Whatever the next one is.
2/5.
Not whatever the
And
next one is.
Whatever 4/3 times 5 is. X
5 over 1, so 20 over 3.
to the 1/3.
Good.
Okay, so it's
Negative 4/5 x to the negative 7/5.
Yeah.
ooh, sine.
We're getting there.
And this is our homework.
It is a homework. Yeah,
We only have like 50 problems.
but it was 5 minutes.
It took 5 minutes. This took us like 20.
Keep them going.
I don't care.
4/3 x to the negative 1. Or
To the
1.
one.
1.
4/5 x to the third. I don't know what to do.
When you just
What
do
do you
that
mean?
for count the x's.
So now I've got lots of things. So you're going to do it to each piece.
Yes.
Okay, so you
So it's
got
gonna be 15x to the negative, or to the second, so that's
and then 3.
3,
Oh
It's the
wait.
derivative of a constant.
0. 36 x
seconds
squared.
minus 2.
is,
This is stupid.
3 minus, or plus 2. Yeah,
To the negative side.
Oh, yeah, it's negative.
10x to the first.
This is
Minus 1 over x.
minus 1 over x squared. So how do I fix that?
X.
This one probably deserves a rewrite. So you're going to go minus x to the negative 2. Now take the derivative of both parts. So you're still going to get 10x, but then you're going to get
Plus
2x.
plus 2x to the negative third. Okay, now let's rewrite this one so it's a little easier to see. You got x squared plus 2x over x. Well, that's complicated, sort of.
Do each part individually, but bring the x up top first.
So
Well-
it's gonna be x squared plus 2x plus x to the negative 1.
Simplify first. Okay.
So
Bring
it's
down
not
x.
x.
Yeah, because you could factor it and then cancel, or you can break it up under each piece so that you'll have y equals x squared over x. What's that really? X. And then this one would be 2x over x, which is really 2. So now when I take the derivative of that,
You
Just get 2.
no, the 2 will cancel, go.
get x.
You don't get x.
You get 1.
0.
You get 1.
1, yeah.
Oh,
Right? Same idea on this one, so don't let it confuse you. So I rewrite this, I'm going to get 2x squared plus 5x minus 2 all over x. You can do the same thing on that one and break it up into 3 new pieces. So I'll get y equals 2x squared over x plus 5x over x minus 2 over x. What's the first piece simplify to? 2x, this one, and then this one. No.
Or
It's just 1.
x.
Or it's just 2 on
X
x,
to the negative.
No. How can I get this to something that I can take the derivative of?
Keep change flip.
We've done this
X to the negative.
somewhere. It's like this one.
X to the negative.
2 to the negative
X to the negative 2. So that's what
Yeah,
you said.
that's what I've been saying.
Nope, that's not right either.
2 to the negative x.
No,
X to the negative 1/2.
2 to the negative x is the same.
this right now, this is
Yes.
one of these.
Yes. Did you get that? Yes.
You guys are just vomiting answers at me.
Yes, we are.
Finally,
I've been saying it.
I got one. 2x to the negative 1. Okay, now when I take the derivative, this one,
2,
this one,
nothing.
gone, this one,
2 plus 2, x negative 2.
good. Okay, so we've done 38 examples. All right. Now for this one's going to take a little bit of things that we have to look at. We'll look at all of these later. The 2 that you guys need to know right now are these 2. So if your function is y equals sine, then the derivative of sine is cosine.
That's easy.
Okay. And if y is cosine, then your derivative of y is negative cosine.
Does it have to have an x in front of it? Does it have to look just like that? Or is it just if there's a sine or a cosine in the problem?
It has to look just like that.
So there can't be like extra stuff off the end of it?
Well, there can be, like if you had plus 3 or 3x, then you'd take the derivative of this, and then you'd take the derivative of this. Just like we were doing before. You do pieces.
It can't be like sine x squared.
Right. You're not ready for that yet.
I'm not ready.
You're not ready. You can't handle the truth.
You can't handle.
Okay? Now, it's kind of interesting to think about how these work, because remember, what is derivative after all? The slope of the tangent lines. So if you look at the sine graph, which we know does this, right? What's happening to the slopes? What's the slope here? Some positive number, right? But what happens to it until it gets there, and then it's 0. So at pi over 2, it's 0. So if you're graphing the derivative, right? It's going to start out being some positive number and get less positive until it gets to pi over 2, and then it should be 0, right? And then what happens to it? It gets negative,
Oh, it's the cosine.
and it becomes increasingly negative.
Oh, now all these curves make sense.
So the derivative, if this is your f prime and this is your f, not prime, then the derivative is actually going to turn out to be cosine. And if you do the same thing, that's why it doesn't go backwards, because if you take the derivative of cosine, it actually turns out to be the sine curve, but reflected over the x-axis, because it starts out as negative. So that's fine. Okay, so those are two that you need to know. So that will take us back to this guy, and we should be able to finish these two off. So cosine. Now this one.
2 plus negative minus sine.
Good. Minus sine of x, because it's the negative one. And I need to get a copy of this worksheet for you. So you have page 115, 1 through 51 odd, plus a worksheet.
I think
What?
And we just did 40 examples in like 15 minutes. I think you can handle this.
I work from 4 until 10:30.
I was talking about the worksheet.
You can do it in between your jobs at your work. They're so fast. You're going to be doing these in your head all night. Every price that you see, you're going to be like, I take the derivative of that.
My prices don't have X's in them. They'd all be 0.
Oh, it's true.
Shit.
All right.